Hi, welcome to yet another release of Dogen, this time for Sprint 18. I've tried playing around with the microphone a little bit, so hopefully the sound is going to be a bit clearer with this sprint. We've had a lot of problems in the past, so hopefully this is slightly better. So as I mentioned in my release notes, there's not a lot to demo in this sprint. There's only one user visible change really, which is to do with the way we organize data. It's more of an internal change, to be honest, but it's probably worthwhile just explaining what it was and where we're going with it, for more context for users, and so you're not surprised when you look at your Dogen installation and suddenly realize that things look quite different. So this is the data directory cleanup. The data directory, so what we'll do is we will just travel through time a little bit. I'm just going to install an older version of Dogen. I'll just use the terminal here to install, say, version 9, which I prepared earlier. If I go to the share directory of Dogen, what you'll see here is you see the data directory here, and then inside of the data directory, first the name data is already sort of a smell that something wasn't quite right. But nevertheless, inside of the data directory, you see a number of entries and of subdirectories, each of them containing a very large number of JSON files of different types. Now, these files were just modeling different aspects of the configuration for Dogen. Certain things that was user-specific, certain things were shared across all users. It was basically one big jumble of configuration files that we were using for different things, such as defining feature templates, instantiating feature templates, profiles, licenses, for example, model maps, and things like modeling groups for different editors, and even the text templates used by certain models. So it became a bit of a jungle, really, for all sorts of configuration-related data. So over the last few sprints, very slowly, methodically, without trying not to break anything, we've moved every single entry in this directory over to the meta model. We modeled them correctly, and we moved it over to the meta model. And so with this release, it's a bit of a milestone, I guess, from a development perspective, because what we've done now is we've removed the last bits. The last entry on that directory shouldn't be there. I'm just going to move in time again, this time to the current sprint. If I now have a quick look, well, the data directory won't exist, but if I have a quick look at the directory, you see now that data doesn't exist anymore. There's a library directory there, and the library just contains the PDMs, as it did before, the platform description models. And if you remember, the PDMs are just basically a way of telling Dogen about things that exist outside Dogen's space, such as the boost libraries and built-in types and the standard C++ library, and so forth for different languages, or for shared things, such as profiles that may be shared across MASD. And so that's much cleaner now, much nicer, and it took us quite a long time to get where we are now. So given that we don't really have many user-facing features, we thought we'd just revisit some of the things that we already have, and just give a quick recap in case you're not familiar with them. I'll just use the existing model that we had for previous sprints and for many sprints before that. So I've already spoke a little bit about enumerations on the previous sprint. So you can declare type as an enumeration, and then all you need to do is to set the stereotype of MASD enumeration for that type, and then declare the enumerators as you'd like. And then what Dogen then does is, if we just quickly go over here to Emacs, Dogen then generates all the code required for the enumeration, as you'd expect. So it declares the enumeration for you, but then it also projects that enumeration across all the supported facets. So for example, it creates a generator for it, which is a bit of a fountain, so you can go look through it. It does serialization support for the enumeration, in this case using Boost. And as we've seen in the previous sprint, we now have the ability to cast using lexical cast to and from a string. You notice, of course, the enumeration has an entry called invalid. That's just because by default Dogen injects this entry, but there's nothing stopping you from getting rid of that and just switching that off if you don't need it. The other interesting thing is in the enumeration we have comments both at the enumeration level and at the enumerator level. These are Dogen comments. So that's enumerations. Of course, Dogen also supports exceptions for a long time. And similarly to what we've done with enumerations, all you need to do is declare a class, call it what you will, but remember to add the stereotype of exception. As usual, can add some comments to it. And what you need to do then is, of course, after you've saved your model, just regenerate it. Best not to run it as root, to be honest. You shouldn't really run Dogen as root. There's no need for it. So if I just run Dogen, you can see here a new exception was created. So exceptions don't really project into other facets that much, not at present anyway. And what you can see here is our standard way of defining exceptions is it uses both std exception and boost exception. In C++, in C# is different, of course. So in the future, perhaps we'll consider allowing a metadata knob to switch off boost exceptions or even std exception in case you want to create your own exceptions. And we're also thinking about allowing inheritance for exceptions. We just haven't had the need for that, so there hasn't been a use case for it yet. Another feature of Dogen, which we use quite extensively, I mean we use exceptions quite extensively, but another feature we use extensively is our object templates. So I'll quickly go through an example here. So if I just create a object template, now the name of the object template is probably open for debate. We've been looking to the literature to figure out what it should really be called. We didn't want to call it concepts because it's a C++ thing, but it's really quite close to a concept. But say, for example, I create an attribute here, and just for laughs, I'm going to call it ID with type string, and I'm going to put a comment, test1, I guess. So once you create an object template, nothing happens really. This does not have an expression in terms of generation. It only exists in terms of the meta model. What it becomes interesting is when you start creating classes, say for example class 1, that use that object template. So for instance, if I say class 1 and I put the stereotype of identifiable, and then for good measure, let's say we create a class 2, also stereotype identifiable. What Dogen will then do is, Dogen will then say, these classes are modeling in the C++ sense, modeling the concept. So it generates the class, but it also adds the properties that the classes have via the concept. And whilst this may seem like a pretty simple, trivial thing, in reality it's changed, it's helped a lot in the way we've developed Dogen, because now when we create classes, the first thing we do is try to break it down into its constituent parts, and instead of thinking of inheritance, we think much more of shape commonalities between objects. What are the building blocks that make up certain objects? And then, of course, there's nothing stopping you from creating a couple of these things. For example, nameable, say. Also a MASD object template. And then let's say with a name, say I've stood string. And you can then say that both of these things are nameable. And then, so you have composition, but the composition is done at this sort of meta model level, rather than in the code. So in this particular case, if we then regenerate, what we'll then see now is, if I go back to my class, of course, as you'd expect, I have now name, which is my second attribute of that class. And then, taking this further, we can then do the logical sort of consequence of this, which is we can start creating, we can start composing at the template level. So let's just imagine I create something called an element, whichever meaning that has this particular case. We should probably choose a much more accurate name, but and then this element then inherits from both of these templates. And as you can start to see quite clearly or quickly, you can start composing objects very easily by first decomposing them into concepts, object templates as we call them, and then recomposing them into higher level concepts. And then, of course, the code generator will generate the same code. So if we just go back to class 2 this time, perhaps, or test data. The definition of class 1, as you can see, we got exactly the same code. But the meta model is now much clearer, because now we're saying, well, there are these distinct concepts, these two distinct templates. They model these two distinct ideas, but they come together into the notion of an element. And now, when you start to create C++ code, you can start to think in terms of generics, and you can start to think in terms of the models or the concepts that you've created in your model. And at present, Dogen does not generate any concept-related code, but of course, in the future, as C++ starts supporting concepts, or even using Boost concept, we can generate some codes that enforces the existence of these concepts, so that when you create your generic algorithm, you can refer to the concept to ensure that it's valid, really, the types that are being passed over to the algorithm. Whilst it didn't seem like a particularly useful bit of functionality when we introduced it all these years ago, Dogen now makes extensive use of object tentacles. You have hundreds of these things, and this really changed the way we do programming when it comes to generic types, and even the thinking about the types. So if we now jump over to next sprint's work, our mission statement really will be to tackle as much as possible Fabric. It's a very simple mission statement. If you remember, Fabric was the meta model that we created at the generation level for both C++ and C#, and it seemed like a really clever idea at the time. A model elements such as CMake lists and other language or the technical space specific items. In reality, after we read more of the literature, this was actually a modeling error. We needed to keep the model, the types in the meta model, the core meta model, rather than create lots of small meta models specializing for technical spaces. So now that we understand technical reasons why this is wrong, we now need to go and fix it. And we started doing that with 4 declarations last sprint, and it demonstrated this is actually quite a difficult thing to do. So we expect the whole sprint to be taken by this work. And that's all we have for sprint 18. Thanks very much for watching.